Hey all, Magi here. I thought I would show you guys a little bit of a twist on an old statistical problem today. So, there are three sets of coin flips here, assuming a fair coin. 10 flips in all. One is heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. The other one is heads, heads, tails, tails, heads, heads, tails, tails, heads, heads. Or 9 heads and 1 tail. Which one is the least likely of these three to show up? Now, the normal answer to this problem is that they are all equally likely because each coin flip is an independent event, which means that the odds of flipping any one of these are all of 1 in 1024. However, we are also overlooking a very key problem that shows up in most of statistics pertaining to science, and that is how many heads and tails are there roughly pertaining to the average, which is normally distributed, or in this case, because there are less than 30 trials available, or 30 flips, we are going to use a t-distribution. And the correct way to measure this is that you'll actually find that the third case of 9 heads and 1 tail is least likely by chance, and I will show this right now. So, I would like to, hold on. So for example, if we go over to here, we can see what we need to do in order to measure this. So the first thing we are going to do is we are going to take the difference of 9 minus 5, which is assumed, and we will, so you see here the standard deviation, what we do is we take the difference, we then do the standard deviation over the error, which is also known as the standard deviation is the square root of NPQ right here. And then once we've done that, and calculate it over the square root of the number of trials we use for the paired t-test, because both are 10. Once we've got that t, we then do n minus 1, or number of trials minus 1 for the degrees of freedom, and then we go to the t-table and see how statistically significant we are based on 9 degrees of freedom and the t-score we get. So going to the calculator, bear with me one second here. Sorry, wrong method. Calculator. So, here we go. From the final case, we have 9 minus 5 equals 4. Good. Now, 10 times 0.5, which is p, times 0.5, which is q, close bracket, square root, equals 1.58. So now we divide that by 10 square root equals 0.5. Okay, so now we divide the, like I said, we divide the error, the SD over N is 0.5, so now 4 divided by this 0.5 equals 8. So we now have a t-score of 8, and if we go back to the t-table over here, where I will change the window again, so let me change over to the t-table, and if we look at 9 degrees of freedom, and the t-value being 8, we exceed the critical value is 4.781. We exceed that, so a one-tail probability, the p-value for the 9 heads and 1 tail is less than 0.0005, or 0.5% probability of happening by chance. So we now know, where did the open office window get to? Damn it, I can't, oh. Therefore, we now know that of the 3 sets available, the first 2 are indistinguishable from each other, but the third one has less than a 0.05% probability of happening by chance. Therefore, of these 3 coin flip sets, number 3 is statistically the least likely to happen because it has 9 heads and 1 tail, as opposed to 5 and 5, which the other two do. I hope you enjoyed this little introduction to a t-test. I will mention that this is the standard test used in medical studies, so this is how they actually determine that the experimental group is better than the placebo group in medical trials and that your medications are in fact working. Hope you enjoyed this little introduction to statistics, and I will see you guys next time.